Hello everyone. In this question, we are going to solve this question of engineering mechanics, which is based on work energy principle theorem. Here it is being given that we are having a block T over here, whose weight is 50 Newton, and it is given that it has been pulled so that the extension in this spring is 10 centimeter. Okay. Now next thing is the stiffness in the spring is given to be 4 Newton per centimeter, and the coefficient of friction between the surface and the block is given to be 0.3. So we need to find here the velocity of the block as the spring returns to its undeformed state, and then we need to find the maximum compression in the spring. So at least at first try to understand what this question is trying to say over here is that we have been given this particular block. Okay, we are having this particular block which is having a weight of 50 Newton, and initially what is happening here is that we have pulled this block such that there is extension in this spring by 10 centimeter. It means that if we are releasing that particular body from this state of rest, then if it moves a distance of 10 centimeter, then obviously there would be certain work done by this particular system, and at that particular case we need to find the velocity of the block when it is having an undeformed state. And the second part is that due to its continuous movement and momentum, that this particular block will continue to move in the forward direction, and then it will try to compress this particular spring. And then at that particular case we need to find out its maximum compression in this spring, that is the value of x over here. Okay, and at that particular position this system will be in a state of that particular spring, that it has compressed to its maximum state, and then it will have a velocity equals to 0 at that particular state. Okay, so these two things particularly we need to calculate over here. So now just see how we can solve this particular numerical over here. As you can see in the figure below, that we are considering the two situations, the position 1 as well as position 2. In this position 1, you can see that the velocity is equals to 0, and obviously the spring is in extension. Therefore the value of x1 deformation is given to be 0.1 meter. But when it has been released, and according to the question it has covered a distance of 10 centimeter, then at that particular state it is going to have a free length. That's why the deformation is equal to 0, and it is going to have a certain velocity with which it will move from that particular position, and it will continuously to compress this particular spring such that it is going to have certain compression. And at that particular state of maximum compression it is going to have the velocity equals to 0. So we need to calculate these two things of maximum compression and the velocity of the block as the spring returns to its undeformed state. Okay, so now let's solve this numerical and let's see how we can solve this particular question. So let's see here that we are having a two position. First is your position first, and next is your position 2. Okay, so in the case of first position it is being given that the velocity is equals to 0 and the value of x1 is equals to 10 centimeter over here. But at the second position its velocity that we need to calculate, and second is the compression in this spring, that is equals to 0 because that is the state of the in which the spring is not in compression or extension, so it is going to have a free length. That's why the value of deformation in that case equals to 0. Next thing, for the work done, that should also move in a certain direction. So for that the displacement is given here equals to 10 centimeter. So now we are going to place all these values in the question of in this question and try to figure out what this work work done equals to change in kinetic energy says. Okay, so from here we are going to use that work energy theorem, and according to that whatever the work done will be equals to the change in the kinetic energy. Fine, so if you look here, so that is equals to change in kinetic energy. Okay, so just a second. Okay, so we can write that equation again. So that work done is equals to your change in kinetic energy. Fine, so from here we can get the equation of the work done. So due to the friction force, the work done will be here equals to minus of 0.3 into of 50 into the displacement is 0.1. Fine. Now next, due to the spring, there will be again a work done that will be half time of K, that is 400 times of 0.1 square minus of 0 square, and that will be equals to the change in the kinetic energy of the body, that is half mv square, half of m, that is your mass, and 9.81 to get the value of mass times of velocity square minus of 0. So in this equation, you can see that the only unknown quantity is over here is v2. And if you just solve this equation, then you can get the velocity equals to 0.44 meter per second. So at that particular state, the velocity of the particle is equals to 0.44 meter per second. Now in the latter half of the question, it is asking that if that particular block continues to compress the block, then what would be the uh, maximum compression in the spring. So let's see the last case, how we can solve that particular last case. So in that case, you can see here that the case is looking like this, that now the spring is being further compressed. Okay, so now this spring has been further compressed, so that if this is the initial state of the spring. Okay, so we will take again the two situations and just try to figure out what would be the maximum compression in this spring. So that at first we need to figure out what is the distance traveled by the block. That will be equals to x, that is the compression in the spring, plus 0.1. Okay, so that is the total distance that will be traveled by this particular block. And if let us say that this is the case first and this is the case 2, so this is position 1 and this is your position 2, you can take 3 also over here. Okay, so at this position, you can see that the velocity is equals to u0, because that is having a state of rest, and the compression will be, let us suppose, is equals to x over here. Okay, and at the position first, we can say that the velocity at that particular state would be equals to your 0, because that was held in that particular position, and at that particular initial state, that value of x1 was equals to 0.1. Fine, so again we can work out on the work energy principle, and we can get the value of maximum compression, that is unknown quantity s over here. We can just use that equation and get the solution for this particular question. So again we will write that work energy theorem equation, and let's see what the equation we can get. It is equals to the work done, which is equals to the change in the kinetic energy. Okay, so here the work done is equals to, again, due to the frictional force, it will be negative, it will be minus 0.3 times of 50, that is the value of n, multiply by the displacement, that is equals to 0.1 plus x, plus next will be the strain energy, that will be half times of k, that is equals to 400 times of x1 square, that is 0.1 square, minus of x2 square. Fine, and that will be equals to the change in the kinetic energy of the body, which will be equals to 0. Final minus initial equals to 0. So just if we solve this equation, then we can have a quadratic equation that will give the value of x. So the equation, this equation gets reduced to minus of 200 square minus of 15x plus 0.5 equals to 0. And if you solve this equation, then we will get x is equal to 0.025 meter, which means that at that particular state of 3 position, the spring gets compressed to a maximum compression of 0.025, at which it is having a velocity v3 equals to 0. Okay, so by this way we can solve this numerical. Now let's see next numerical. Okay, now I think this question is again very simple question. So in this question, you can see here that we are having a spring system, two spring system. This is first spring and this is other spring, and that both of these springs are holding a mass of 5 kg. Okay, so the stiffness in the question of it is given that the spring is having a stiffness of 0.5 Newton per centimeter, and they are lying in a horizontal plane, but that is in initial state, that is again having initial tension of 1.5 Newton. Now the next thing is that we are just pulling this object in a downward direction. Obviously, in that case, these two springs will be stressed, and that ball comes at a location of 15 centimeter below this horizontal level. So you need to find here what will be the velocity after it has fallen through a height of 15 centimeter. So if we release this particular object from this particular point B, okay, so if we release this particular object from this point B, so what is its velocity at this particular height of 15 centimeters? So in this question we need to calculate this part. Okay, so now let's see how we can solve this question. So in this you can see that we will again use certain equations to get these values. Okay, so let's say that it is given in the question that the initial tension is equals to 1.5 Newton. So you can write here that tension is equals to, since k times of x. Okay, so since tension is equals to 1.5 and value of k is 0.5, so we can have that deformation in the spring, and that will come out equals to the 3 centimeters, so that you can get the deformation in the spring over here. So if we try to figure out what could be the free length of the spring or unstressed length of the spring, that is of more importance, then we can have that free length of the spring. Since it is given that the stretch length of the spring is 20 centimeters, so we can just work out on there and we can have a free length of the spring, which is this free length of the spring will come out to be 20 minus of 3. Okay, so and that will give us 17 centimeter. It means that if we are having a spring that is neither in compression neither in tension, that then its free length will be equals to 17 centimeter. Fine. Again, now we will work out on the two positions and try to figure out what are the velocities as well as compression in these springs at these two positions. Okay, so let's see that if at the position first, that is the initial state of the ball, and when it is released, and the two is the next position of the ball. So at the position first, then the velocity of the ball is obviously zero, since it is in a state of rest. Next, the initial compression in the spring is equals to 3 centimeter. Fine. But when it is being released and it is at a position of 15 centimeter, then it is having a, let's say, velocity v2 that we need to determine, and the velocity of next the compression in the spring or elongation, that we can figure it out. Let's say that we can use the Pythagorean theorem to get the straight length of the spring. How? Let's see how we can get that value. So let's say that this is the ball which is being released and it comes at this particular position. Fine, and this is the unstressed stressed spring over here. Fine, so we can use the Pythagorean theorem and get this and get the value of this particular length of the spring. Okay, since in the question it is being given that the length this length is equals to 20 centimeter and this length is equals to 15 centimeters, so we can figure out and we can get this particular length over here. Fine, and then we can subtract the free length of this spring from this, and we can get this value of x2 for this particular spring, and it will come out to be 25 minus of 17, which will give you 8 centimeter. Fine, so these are the at two position 1 and 2, we can by this way get this value of velocity as well as deformation in the spring. Now we will use the work energy principle and we can get the value of the velocity at the latter position. So again, by using the work energy theorem, we can say that this work done is equals to the change in the kinetic energy. Fine. So we can say that this work done by this particular particle, let us say that its weight is 5, and that will give us the weight and multiply by the distance that it has traveled, that is 0.15. Next will be the uh, work done by the spring. So let's say that it will be half of k, that is 50, into x1 square, that is 0.03 square minus 0.08 square. Fine, and that will be multiplied by 2 because we are having a two system of a spring, and that will be equals to the change in the kinetic energy of the particle, final kinetic, and minus of initial kinetic energy of the particle. Since final is equals to half of mv square, that is 5 v2 square, okay, minus of 0. So from there, we are having only one unknown over here, and that unknown is V2 that we need to find out. And if you solve this equation, then you can get this value of V2, and that will come out to be 1.68 meter per second. Okay, so by this way, we can solve this numerical. In the next video, we will some other numericals on based on work energy principle. Okay, thank you.